Hi folks, as we talked about in the CAD suite yesterday on the 3rd of October 2022, I kind of introduced things by explaining that the MakeLab are now kind of refusing to help debug people's 3D models prior to 3D printing. They're just so overwhelmed with work that they can't do it. Some of these problems are very difficult to solve, and it basically comes back to the person making the model to make it in a 3D printer friendly way. So what we're trying to do with all this material here is kind of throw all these kind of tips and tricks and nuggets at you to show you how to create models that are going to be more successful on a 3D printer. Success can be very fickle with 3D printing. A temperature change in the room can knock a 3D print off. It's as a draft, something like that. It can really be something very simple. Just recently I've been struggling with some material that I just don't think was plastic enough, and it just wasn't very sticky, so I kind of had to throw some material away. But there can be all sorts of reasons why something doesn't work quite well. But it really boils down to the model being in the correct format. Software like Revit it's not intended for making models for 3D printing. It's intended for delivering a building on site. SketchUp, if things are done correctly, can easily generate models for 3D printing, but often there's material and bits of geometry left in that cause problems. Non-manifold edges, little gaps, overlaps of surfaces, and you really need to be really up your game as far as the quality of your modeling goes. And that comes from your 2D CAD through to the 3D CAD, so it's all part of the same process. So this is the kind of the model that I'm kind of using as the vehicle, and the next examples are all based on this. So it's familiar to you, you've seen it. So you kind of got a model here where it's all one piece, and then here something a bit more clever where it's in portions that interlock with each other. But to do this, you need to allow some tolerance. As you'll see in the later slides, there is a very thin gap that runs up between these, so that you can actually make it. If it's done to the exact same sizes, it's too tight and things won't go together. You can see here on this bit of model, if I put it to 2D wireframe, these little pyramids, I use these extensively on my models to help get a better stick down to the printing bed. So you subtract these little pyramids, and it creates little pause points for the printer nozzle to kind of, like a tack weld or tacking when you're making a piece of clothing. You put in the pins first, and then you come along and do the sewing. So very similar principle, and they're so small that they don't often show up on the model. Okay, so that's just a wee intro, and we'll get things moving. What I'm going to do is just kind of run through 3 scenarios for 3D printing. The first one is the kind of lazy one, where we just join everything together as one solid, one watertight solid, and send that. The second one involves more work up front to ensure that things connect properly, but it does allow you to have different materials, and is kind of a bit more sophisticated. The third option, which is a bit of a hybrid, is to print the portions all in one job, but as separate bits. And the advantage of that is that it's kind of fairly convenient. It's one job, but there's a few problems with that, in that you can get stringing between the objects as it moves from one object to another. So it's dragging the filament across space, across fresh air, and that can drag out lots of stringing and be a bit untidy. It's also a wee bit risky in a way. Okay, so what we'll do is we'll send these out, and quantify the time, show you where the time comes from. So we'll send this single piece out first. So STL out. AutoCAD can't generate OBJ files, which are another type of model that 3D printers will accept. Okay, so we'll pop this on the desktop. Okay, then we go to the, then what happens is you go to the slicer software and we load that particular shape. So it's Frontage 3D Print, and we give the software a chance to work out what's going on. So let's have a look. We can see the model. Okay, so we can see it's all intact, everything's there, it's all joined together, which is kind of easy. The column itself doesn't need to be so thick as one of the other versions where we're trying to do connections, and so there's a time saving there. But the problem with this, as you'll see in a minute, is that it takes a long time, and a good chunk of that work is in what we call the scaffolding. So this is trying to support the truss because it's floating in midair. There's nothing holding this up. It can't 3D print plastic into fresh air. So that's the problem here. If we get closer up, you can see the individual paths that the 3D printer is going to do. So huge amount of work, and you can see it has to go around there 5 times to create one layer. So it's a really useful tool to kind of analyze your model with. Okay, so we'll catalog that time, 14 hours and 40 minutes, and I'm just kind of building those up on this slide as well. So what I'll do is clear the platform. Okay, and we'll load the truss on its own, so you'll see the difference. So if I just bring in the truss, so F truss, let's have a look at that in normal. So it's on its own. I intentionally kind of sliced the bottom of it so that there would be no scaffolding. So we see no scaffolding there. The pale blue is what's called a raft, and that just helps it stick to the base of the printer. Okay, so you can see there it's just 1 hour 30 minutes. Okay, that's very low because it's not very high. The higher an object is, the longer it's going to take to print. So we'll clear the platform, and let's load one of the other portions. So let's say F bottom. So this is the bottom portion of the object, of the column. Okay, so you see here we're about 4 hours 50 minutes, 4 hours 55. Depends where you put it on the base. You get slightly different time depending if it's close to the origin. So the time varies just slightly. Okay, and this model is faceted. It's not a smooth model. It was unintentionally so, just to make it less heavy duty for visualization. So we put those times into here, so you've got the bottom part of the truss and the top part of the truss, and then another option is to bring it all in as a kit. Okay, so we added all these together, you got 11:05, so about 3.5 hours quicker than doing it in parts. But some of the time is lost in making these connection options and testing that. But as I say, the advantage is that you can use different materials for the truss from the column. Okay, so the last one was to send it out as a kit of parts. So we've kind of nested these as close as we can so that it takes advantage of the raft, so it's not building extra rafts everywhere. Okay, so let's load this in instead. So we clear the platform and we load the kit, F kit. So this is always going to look quite cool. Okay, you can rotate these to get a kind of a better position. Sometimes you need to so that it fits, and you can reposition it wherever. And we're getting about 11 hours 40 for the kit. Okay, but the problem is that it's all going to be one material because it's all in the same print, and when the print head moves from one object to the next, it can drag out little bits of string, little bits of plastic along the way. Okay, so that's generally how that works. Now I'm going to open another file just to show you what happens when it finds objects that it doesn't like to work with. So let's see if we can find it. Beam and Truss Mini. Okay. So this looks, looks like a decent model. If I shade it, it looks good. It looks great. It looks eminently printable. Let's just put it without the lines so it looks a bit easier to see. Okay, and we'll clear this first, clear the platform, and then let's send this out and see what we get. So if the only option from AutoCAD is STL out, and there we go, there's a problem showing up already. There's only one solid object here. Okay, so as it says here, it's got to be solids or watertight meshes. None of these are watertight meshes. Okay, so that's the only object that's going to go out. So let's see what it happens when it comes in. We can leave that name, that's fine. And if we load that, what was it called? Truss Mini. Can't see the wood for the trees here actually at the moment. Where are you? Did I save it to the right location? Let's just do that again because I lost my file. So STL out, grab this, yes, desktop, not Beams and Truss Mini, sorry. I hadn't saved it anyway, so save. Okay, let's load it. That's better, Beams and Truss Mini. There we go, that's the only bit that's going to 3D print, just that tiny portion. No use whatsoever. So I'm just going to pause the video just there. I'm going to open Rhino. Okay, I've brought the drawing into Rhino and just hit the shade button, and it looks quite seductive, looks quite cool. But what we'll do is export this. Select the objects. Okay, so we've got lots more options with Rhino. So we can choose a huge number of different files, but OBJ is the other type of file that generally a 3D printer will work with. So we'll export this as an OBJ. Let's just call it Beams and Truss Mini. Okay, I'll keep the same name and save. You have to watch out for the direction things are facing with OBJ files. Map Z to Y, no, we don't want to do that, so that's good. Okay, more polygons, that's fine. Okay, so if we go back to the slicer and clear this and load the OBJ, so OBJs get a different icon from my machine, a bit easier to see. Okay, so we've got something here. Okay, you think, oh great, this is going to 3D print. It's like 4 minutes, that's rather quick. Okay, so let's have a look at the actual information that's going to get sent to the printer, and it's a fail. There's nothing it can send really. So we know, we've got a model that's not happy. Okay, so it has no kind of solidity to it, whether it's a solid or whether it's a watertight mesh. So that's really kind of critical. Rather than put all this on MyDundee, I thought this was kind of a bit easier. You can read the notes and you can kind of pick things up and stuff. So this is where I started on Friday. I thought I'm gonna have to make a model. Let's get this done. And I had some greenhouse glazing plastic kicking around. I did have some Perspex that I found in the 5th year studio. And it was like way too difficult to cut. It's
really tricky to cut. You need saws or you need a laser cutter. But this stuff's really good, 2mm acetate, B&Q greenhouse, and you know they're 600mm by 600mm sheets, and all you need to do with that is score it. So you can just run your knife across it about 4 or 5 times, get quite a deep score on it, and then kind of snap it like when you see people breaking glass. You can start at one end actually. You just get it, just runs down the glass. So there'll be failures. You know, mine was a bit rough on this side. If you run your finger down there, it's pretty yucky. Luckily, it didn't wreck my bit. It spoiled what was left. Okay, but to kind of keep the plastic stood up, just layers of Kappa board instead of wood. You know, wood's always more difficult to work with. This Kappa board stuff is really, really good. Like I said, I simplified the connectors at the end, so I actually had something I could glue to the glass instead of trying to make little bolts and things. It's way too much detail. Didn't bother trying to model the framing for the glass, just drew the lines on. It's clear enough, you can tell kind of what's happening. And then for the cable, there's a tensioning cable that stops these kind of waggling up and down a bit. That's just balsa wood, so it's light as a feather and just a bit of glue, and that's solid enough. You know, balsa's amazing stuff to work with. Awkward to cut unless you've got a little saw. A little hacksaw is really good for balsa wood instead of a knife. So what's happening here is this wee smaller version, so you can pick that up and put it together if you want. But you'll notice that it's a little bit loose, so the truss goes in between there. If you put the truss in between, so it's just carefully kind of sized. So you notice it's just a little bit flappy. Okay, this was a bit too tight, so that was 0.2mm tolerance. That was 0.3, so 0.25 would have been great. So it's down to that kind of accuracy. You know, 1/4 of a millimeter is, you know, virtually nothing. So that's the kind of detail through there where you see that there needs to be a gap. There needs to be a tiny little bit of airspace, and that's where the CAD accuracy comes in. You know, if you've not got the accuracy in the drawing, you can't get that through into the model. So this is the way I printed them. You see over there, there's a brim. So actually, that one printed with a brim. I thought, I'll give it a go. I don't use brims because they don't work very well, but I'll give it a go this time, and it worked a treat. I thought, brilliant. Tried to print the second one, the thing just lifted off and just was the usual nightmare. So I went back to the raft. Okay, so that's what this is. So the raft is, you throw them away, they don't keep them, so these peel off. It's always quite nice, it's because you can't let you unwrapping something.
Satisfying.
Yeah. But this is a bit rough down here, but this is where I've told it to do these little nicks, these tiny little marks. See, but it's like you're going along and dabbing the glue. It just makes it bang, it's stuck. It's not going to come up if you get these little nicks on it. So did I write that on there? Where did I draw it? I can't remember. I drew a little doodle of the nicks somewhere. I can't see it.
I suppose you can just sand these down.
Yeah,
like
yeah,
models.
just a wee scrape along the edge and tidy that up. It's just come straight off the raft. It hasn't been touched. And then, you know, just glue the other bit on to make it more solid. We're not aiming for perfection. We're trying to get a model done in the right amount of time.
This can be sanded as well, yeah?
Yeah, yeah. And you do end up with a few tools. You know, you can definitely tell the underside. You know, they're pretty ugly underneath, so you kind of be aware of that. You know, like, you know, I wouldn't just kind of make 2 of these and have one of them upside down, because that one's yucky compared to that one. See what I mean? I would actually print one that is the other way around, mirror it properly.
It's not completely solid, is it? It's like walls and then.
It depends. This one's pretty solid because it's narrow,
Yeah.
but this one there is a lattice in there.
Okay.
You can see it on the raft. You can see it on see it on this one. It's got like a honeycomb
Yeah.
inside, so it saves a lot of time.
Mhm.
So it saves a lot of material and a lot of time if it has that in it. You can specify how much of that you want,
Okay.
but anything more than about 15% is a bit of wasted time. If you want it stronger, you should make the walls thicker instead of more honeycomb. So we'll move around. Let's just keep this so we can see what we're talking about. Okay. So this one was kind of these two are together. So we're moving up a scale. So that was a 1 to 20, up now to 1 to 10. So you're kind of into slightly different issues. You know, how we're going to kind of work with this. And do I want to show different materials? It'd be nice. It's nice. It explains the model much better if it's not all one color like that. You know, you get different materials. So you know that kind of forces some kind of connection issue. It's like, is there enough surface to just glue it on? Not likely with that. That's gonna, any glue is going to struggle to keep that together. Okay, so then it was like, right, okay, we need to do some kind of socket to get that to work. So this is where the tolerance comes in again, that 0.25 millimeter. That hole has got to be 0.25 millimeters bigger than this, or it's not going to go in. Okay. The scaffolding comes into play again as well. Okay. So I 3D printed it like this, and I only did half of it so you could see inside easily. Okay. But if we just put a box on the back, there would have need to have been some scaffolding below it. It would have had scaffolding all the way to the ground again, so that's more time, wasted time. So that's where this little slope comes in. If you angle things, and I usually work at sort of less than 40 degrees or steeper, and then the 3D printer can deal with that. It can just make the next print a slightly hang over, a tiny bit, and it just creeps its way out on these angles. And it's sometimes it does it really well with a bit steeper than say 45 degrees even. You can see a little thing here, this overhang tester. It's managed at 35 degrees, no problem. Okay, but it did need some scaffolding inside the holes, because there's an overhang inside the hole which it had to support. But that's a lot easier than scraping all this off all the way down. So it's just a sharp little screwdriver, and just out you come. Give it a bit of grief, and it gives up pretty quickly. It's only just tagged on. It's not really solid on. It's just touching. It's just enough for it to hold the filament for a few seconds until it dries.
Quite like the rock, then we can just quite like the rock.
Yeah, it's just tacked in small bits. It's not really stuck on badly, stuck on tight. Other thing about this, what was it? No, somebody said, well, why didn't you print it like that? I says, well, I could have done for just that half, but if it was the full thing, there'd have been loads of scaffolding in here. So it's like, well, you win on some directions and not others. So another thing, the scaffolding, which I didn't realise until recently, I was making a really crazy big model of the Lower Monument War Memorial, and there's some big chunks at the bottom, and I'd done everything I thought was right about doing the angles and stuff all the way on the inside, added extra bits, and it was all looking great. And it's like every time I took it into the slicer, loads of scaffolding. It's like, what am I doing wrong? What am I doing wrong? And I kind of twigged that it's not just about the overhangs, it's about the overall stability of the shape. It's like, if that shape wants to fall over, then the scaffolding's needed. So it was putting it in for stability, not just for dealing with the overhangs.
So at that point, would you build your own support in order to keep the material down?
I took over and basically built a little wall inside, just a thin, tall wall, just enough for it to keep it up. And it was like, and the minute it went back in there, scaffolding disappeared. I get it now.
It's the same thing like you said for angles, the curvature of a wall. If it's not too curved, like if the curvature isn't that great, it'll just build it by itself without needing scaffolding underneath.
have a look at that one in a second. Okay, these little white ones here, you'll see it very clearly on that. So we've got a curved overhang. Didn't need it for the steep bit, but once it gets to the more horizontal, that's when the scaffolding was needed, and it decides where that is going to happen.
Is it uniform, or does it like change based on the stability of the object?
Stability as well, yeah, because these are quite thick.
Yeah.
You know, if it was reaching over here and it was quite thin, there's a chance it would just do that.
So it'll start probably earlier than later.
Yeah, absolutely. It's one of the models we got for first years is it's a building in Essen. It's just a concrete box with loads of holes in for windows. Really kind of random looking thing. And to get it to print, I had to kind of tilt the whole model at 45 degrees. And what I hadn't got is enough support. I hadn't put any support outside. And it was like, it started to fail. And I was like, what's happening? I didn't realise the whole thing was just tipping over. So, you know, I had to intervene on that one. It was beyond what the software could recognise as unstable. It was like completely unstable. And so I just modelled some little legs.
Oh, that you can snap off.
Just touched on, yeah, and you just snap off and a little bit of sanding and clean it up. But you know, it's a really great way of making models, but there is, you know, a few things to bear in mind. Get in there. Okay, so that's the angle there. So this was a big moving up again, scale 1 to 2. So this is kind of like a wee model of the glass connector. So, you know, very mundane shapes, but you know, if you left this to be scaffolded, there'd be scaffolding everywhere, all the way underneath that, underneath here. That would be crazy to do as well. So it's all in pieces instead. So it just goes together like a wee kit. But that's quite unsightly. You know, the top of that is pretty ugly. You know, what do you do with that? You maybe, you know, if you did it out of a simpler, non-shiny material, you could just paint it. You know, you might be able to put enough paint on there, a bit of sanding, but it's going from hole to hole, and you see the very last bits of movement. Not much you can do with that. Okay, but you know, problem with this, when you're going up a scale, you know, it's great for inspection it and testing an object, but the time it took to print was just painful. So that's 13 hours for those bits. But I was asleep for most of that. Just set an alarm. It tells you how long it's going to take. So you just set your alarm, get up, and which you can't do in the make lab. They're not there all the time. It's manned from, you know, kind of 9 in the morning until about 9 at night. But you know, they generally don't like leaving the machines on overnight.
So you can't have like 24-hour prints.
You'd have to kind of agree that with them.
Pause?
Generally, they will pause. Yeah.
Right.
Yeah.
Oh, so they just pause it and
Yeah,
then
they can pause.
restart.
Yeah.
Okay. That'll take really long then, 24-hour print.
Yeah, it take nearly 3 days, but that's why they've got a lot of machines. So you're not hogging the whole
Yeah.
thing. So this wee thing, if you want to play with this, is just for testing like the tightness. So that's the smallest one. You know, that's too tight, 0.1 millimeters. That's going to be. You've got a danger of breaking your model. You try and force that onto a model. I wasn't too happy with these. They're too tight. I don't know. You end up snapping them. But then I've just got different sizes. So move up one, and then you can see it's kind of usable. So you often see these in kind of people are kind of tested, get their own little testers for different materials, because a different PLA, even different colour can behave differently. That one's not going to work the same as that. That one might be tighter than that one, given the same dimensions. It can be quite fickle. You have to do little tests all the time. So let's have a look at these last bits here. So kind of talked about this, about the overhang angle, and you know, this one's okay on 30 degrees. Sorry, it's scaffolding on 30 degrees, but it's happy with 35, 40, 45. And when it gets to to the flatter bit of the curve, it's introduced the scaffolding there. But like I say, these are quite chunky, these are quite thick. So, something that's, even if it's the same angle, there's a lot more holding it onto the ground here. There's a lot more stability than something here that's very thin and is likely to sag a bit and might need a bit of support. So another consideration is the kind of smoothness of the objects. So if we did a sphere in AutoCAD and sent it out, just as I've done, I just use the STL out command and not do any changes, it's at that quality level, 0.5. So we can see the facets on it. So you see they're not big, they're not big facets, but it depends on the size of the object. If this was a bigger ball, it's not going to be huge because it won't fit on the printer, but if it was like 5 or 6 times that, then they would be more noticeable. So, depending on the size of the object, you might need to go to a facet resolution of 5 or 10 so that you get something smoother. That doesn't impact on the speed of the printing because it's about the same amount of material, it's about the same amount of movement. It's the kind of file quality, but the file sizes can jump dramatically. But that's usually not an issue nowadays either. Storage is not a problem. So this is the same thing, facet res on something like a dome, and then on just a simple arc. You can really see the facets on when it's on the lowest level, 0.1. But 1, 5, and 10, pretty similar. There's not much to call between those three. So feel free to pick all these up and explain, mess around with them. And then the last one here, the brim one. This is the choice of the guys in the Make Lab. This is what they will generally use instead of the raft, which takes a lot longer to create because that goes under the whole object, 4 layers thick on the raft. But the benefit is that the top of the raft is absolutely flat, whereas the brim is so thin. If the deck of the printer isn't absolutely level, the brim isn't level either. It's so thin, it comes through with it. And this shows a very poor stick to the base. It's completely lifted up in one corner, and that's why the people in the Make Lab are there all the time. They're kind of keeping an eye. They'll set a print going, they'll have a look at it, make sure it's getting off properly, and then they can leave it. But that's maybe about, for that print, probably about half an hour or something. Noticed it and it's like, good job you did, because it was going to be doing something much bigger and I'd have been wasted a lot of time. So you do have to kind of keep your eye on them. So I kept this one, I glued it back on because it was such a bad example. It was good to keep. So that's kind of my kind of show and tell info at the moment. We'll kind of build on this. 3D printing is only going to get faster and easier, but the modelling is the key. It's not going to be able to kind of make amends for weak models that are thrown at it. It's not a miracle worker. Quite a few people are kind of getting models from things like Revit or even SketchUp. SketchUp isn't 3D printer friendly. You have to be very careful that the objects are closed objects. SketchUp's got it's got its habit of splitting things and letting you pull shapes off wherever you want, and that ends up with all sorts of geometry stuck inside as well, and it really doesn't go very well with 3D printing. So start as we mean to go on. Okay, right, let's do a little bit of modelling. May as well get something done. Switch this off.